Hello out there. This is online class number 1 for Math 125, fall 2012, and of course my name is Perez. As we saw last time, when presented with raw data, you ask yourself the main question: where is the data center? And we saw last time in section 3.2 there's 4 ways to measure: mean, median, mode, and mid-range. And that's in section 3.2. All right, well, we want to consider 2 data sets. I'll call them data set number 1 and data set number 2. Let's look at data set number 1. Consisting of these values: 49, 50, 50, 50, and 51. And let's consider data set number 2. Number 1, 50, 50, 50, and 99. Well, if we consider these 2 data sets, we can see with some easy calculations that the means are the same, the medians are the same, the modes are the same, and the mid-ranges are the same for both sets. So let me write that down. The mean, of course, for both sets is 50. The median is 50. Simple calculation can tell you that. The mode of both sets is 50. And the mid-range of both sets is also 50. Let me write that down for both sets. But as we can see by looking at both sets, the nature of the data is very different. And we'll need something more, we'll need something more than simple measures of center to discern between the behavior of these 2 sets. In other words, we need to measure spread. Spread or variation. Clearly, data set 2 is more varied, more spread out than data set 1. All right. How are we going to answer this question? All right, after we answer the first question, where is the center, our second question will then be, how much spread or variation? And as we'll see, there's a few ways we can measure that idea and attach an actual number on that. All right, we need a numerical measure of spread, or of course, variation. All right, enter section 3.3. That's what section 3.3 is all about. The title of it in the text is measures of variation. And essentially there are 3 measures of variation. One is range, one is standard deviation, and the last one we'll talk about in this section is variance. Okay? All right, so just like in 3.2 we had different measures of center, in 3.3 we'll have different measures of spread or variation, and you'll pick one or the other based upon your individual problem data needs. All right, let's talk about range first. Range is very simple. As you might have expected, it's just your high value, take away your low value. I won't even bother with an example of this because it's so simple. Let me make a note. It is a crude but quick measure of spread. Of course, the big drawback, as you might have predicted, it's vulnerable to outlier effects. It is totally dependent on outliers. So if you've got fluky data susceptible to fluky values, you might not and probably will not pick range as your measure of spread. All right, next one we're going to talk about. Standard deviation. Now, you may have heard about this before in other math classes you've taken, and it is by far the most used measure of spread. Let me give you a formula for standard deviation, and I'm going to build it up from first principles here, and then I'm going to label the result and talk a little more about it. To compute your standard deviation, you need to take each data value, and remember x is our variable indicating all possible variable data values. From each x value, from each data value, you subtract the sample mean. Of course, that means you have to compute the sample mean first. Then, I square those differences. Then, I add up those squared differences. Then, I divide by the sample size, take away 1, and then I take the square root of this entire mess. Whoops, I missed that. Let me try that again. Getting used to the eraser here. Very good. Getting better at that. All right, this is your sample standard deviation. Generally, in statistics literature, it is symbolized with a lowercase letter s. In Texas Instrument language, they call it cap SX. And you can actually calculate this with your TI 8384 calculator in statistics mode. All right, little s in the textbook and in the literature, cap SX in TI language. Okay? All right, so there's our formula for standard deviation. Informally, it is an average distance from the mean of any particular data value. And this is probably the most used and informal definition of sample standard deviation. All right, it is by far the most used measure of variation. It takes every data value into account. Let me write that down too. Takes every data value into account, much unlike the range, a crude measure of spread I gave to you before. All right, computing your standard deviation, sample standard deviation by hand. Let me get a new screen here. Give me a minute. All right, seemed to work all right. Let's give you an example. Computing standard deviation by hand. Well, we're actually going to use the calculator a little bit, but I'm going to show you how to compute it with the table method. Right here and now. Okay? Let me resize the canvas. I think I'm going to need a bigger canvas here. No, that's okay. All right. Here's a data set. 1.2, 2.4, 3.7, 9.8, and 11.4. And I previously computed the sample mean from this data set, and it's 5.7. All right, to compute the standard deviation, what I'm going to do is create a table. I'm going to list all of these data values. I'm then going to subtract the sample mean from all these data values. I'm then going to square these differences from the mean, and then the sum of this third column is going to be the numerator of my standard deviation calculation. Let me go ahead and subtract the mean here. From each one of these, I get a minus 4.5, minus 3.3, minus 2, of course, 4.1, and 5.7. If I square all these, 20.25, 10.89, 4, 16.81, and 32.49. The sum of this column is the summation of all the squared differences from the mean, and that is what I'm going to use for a numerator in my standard deviation calculation. If I add up this third column, I've done it previously, and it's an 84.44. Now I'll go back to my standard deviation formula. Over n minus 1. This numerator is the sum of this third column. So under the root sign, in the numerator, I've got 84.4. Your sample size is n minus 1. So that's 5 minus 1. You've got 5 elements in your data set. So that's 5 minus 1, which is 4. And I want to take the square root of this mess. And if I grind this out on my calculator, I get an approximate standard deviation of 4.59. Okay? Let me put a box around this, and I have successfully computed my sample standard deviation from the above data. All right? All right, this is my result using the table method, which I've described above, and I sometimes refer to this as the by hand method. Right? Of course, this is very tedious, even for a sample size 5 data set. It's somewhat cumbersome. We can also, as you might predict, compute SD, standard deviation, with the TI 8384 in your stat mode. And I'll continue that on in part 2. All right, so let's take a little break and access the part 2 of this online class 1 when you're ready.